Here we have question 9 from 8C. We're given T0 as 100, the temperature of water in a kettle. Ambient room temperature is A. In accordance with Newton's cooling law, the temperature of the water in the kettle after n minutes is given by this difference equation here. We're asked to solve it, given two factors. K is 0.05 and A is 20. So let's rewrite it as Tn is equal to Tn minus 1 minus K, which is 0.05, times Tn minus 1 minus A minus 20. T1, if n is 1, will be equal to T0 minus 0.05 T0 minus 20. So we can simplify this. T1 is equal to T0 minus 0.05 T0, and then plus 20 times 0.05 is going to be a 1. So we're going to get T1 in terms of T0 is 0.95 of T0 plus 1. So let's get T2 and subsequently Tn in terms of T0. We already have T1 in terms of T0. T2 is equal to T1 minus 0.05 T1, and is 2, T1 minus 20. We have T1 up above here, we need to substitute it in. So T2, similar to the first one, is going to be the minus 0.05 T1, so we're going to get 0.95 T1 plus the 0.05 by the minus 20 plus the 1. So in terms of T0, T2 is equal to 0.95 of T1, which is 0.05 T0 plus 1, and then plus 1 simplifies to be 0.95 squared by T0 plus 0.95 plus 1. So in this direction we have a decreasing sequence starting with 1 and getting multiplied by 0.95 each time. Just write a few of the terms out, plus it's going to go to position 3 is 2, so it's going to go to 0.95 to the power of n minus 1. So we've got a sequence in terms of T0, and we've got our geometric progression where A is equal to 1 and R is equal to 0.95. So Sn is equal to A, I'll write it out this time, 1 minus R to the power of n over 1 minus R. This should be your 9th or 10th one of these, so you've seen this done loads of times, so we don't need the 1 in front, but it's 1 minus 0.95 to the power of n over, you can write the whole 1 minus 0.95 or write 0.05, and 1 divided by 1 over 20 is 20. So we have 1 minus 0.95 n times the 20, which is going to give 20 minus 20 times 0.95 to the power of n. T2 up here simplifies to b, so it's squared in T2, so 0.95 to the power of n times T0, and T0 was 100 at the top. So bringing this guy down, we have 100 times 0.95 to the power of n. Then we have plus 20 minus 20 of the 0.95 to the power of n. So we have 80 of 0.95 to the power of n plus 20 as solving this difference equation. Then we're asked for a couple of things. just correct the 4 dp to temp after 10 minutes, 1 hour, 2 hours, 10 minutes, 1 hour, 2 hours. So this is just calculator use. 10, 60 and 120. 4 decimals, it's giving me 67.899. Then 23.6856. What's happening here? Temperature is going down as time goes on. And then 20.1698. And if we look at our equation, what's it telling us? It's telling us that the limit of this is going to be the plus 20, because as n tends to infinity, 0.95 to the power of n tends to 0. Therefore, AD by 0, if you want to extend it out, plus 20 equals the max temp. And I think that's what they're asking in the last part, isn't it? Show that the limit of the sequence is 20. Yep. So it always happens the same way. Something has to be equal to 0. Constant has to be there. On to number 10.